So take K to be the set of all possible ij's, so that I and j are non-negative integers that sum up to m. Then the probability of returning to zero, starting from zero after 2m steps, equals this quantity here. So note that each of these terms is a probability of returning to zero after 2m steps, where exactly I many north, I many south, j many east, and j many west steps have been taken. And of course, you have to sum over all possible ij's, which is the set K. Now, this number we are going to actually explicitly compute with the help of a combinatorial identity. Now, first step towards that would be to write it as basically force an m factorial square in the numerator as well as in the denominator. Why? Because this will make it 2m choose m, which can come out of the sum. And of course, this 1 over 4 power 2m can also come out of the sum. Then we'll have a sum of all possible over all possible ij in k of this m factorial over I factorial j factorial square. We can have this sum here. So what we have shown essentially is that this P002m can be written as this. Now note that this set K of all possible ij's, it's this is can also be written as j is just m minus I, right? Because I plus j is m. So I can just write I comma m minus I, where I runs from 0 to m. These two sets are the same. So therefore, whatever we have obtained so far, this guy here can be written as this, except that this j factorial can be replaced by m minus I factorial. And then the sum will only vary from, it will be a sum over I only, 0 to m. So in other words, what we are doing is we are eliminating j from this expression here by observing that j is just m minus I. And thus I will have to run from 0 to m. That's all. Now what is this quantity? This is just m choose I. So therefore what we have got is that P002m is this quantity times the sum of m choose I square from 0 to m. Okay, so we have shown that this P002m is equal to this. Now here is an exercise for you. It's a combinatorial exercise. Show that the sum of these binomial coefficient squares is just 2m choose m. Now there are many ways of doing it. One can use also binomial theorem and compare coefficients and so on. That's one of the ways to do it. Another ways to do it would be combinatorially, and that's the hint I'm going to give you. Now instead of writing m choose I times m choose I, write it as m choose I times m choose m minus I. M choose m minus I is just m choose I. Now if you write it this way, then it's a bit easier to interpret. And basically consider the set 1 to 2m. Obviously, it has exactly 2m choose m many subsets of size m. Now, each of these subsets can be chosen. These subsets can be formed by first choosing an I element subset from 1 to m, and then an m minus I element subset from m plus 1 to 2m, where I runs over 0 to m, all integers from 0 to m. And of course, you choose these two and then take the union, that will give you an m element subset. And that's the only way you can choose an m element subset. You have to choose I many from the first m and m minus I many from the m plus 1 to 2m, and then combine them. And of course, here I will run from 0 to m, and that will give you. So the first thing can be done in m choose I many ways. The second thing can be done is m choose m minus I many ways, and then therefore this will give you this identity. Okay, So this would be equal to the total number of choices of M subsets of size M from this set, which is 2M choose M. So this is the hint, and this is the proof actually of this exercise. Okay, so thanks to the exercise, therefore, since this quantity equals 2M choose M, we can just put 2M choose M here. So that will give us 2M choose M squared 1 over 4 power 2M.